Hello class, today we will be performing the separation of a mixture. The purpose of today's experiment is to separate a mixture of salicylic acid and naphthalene and to further purify the respective compounds by recrystallization and sublimation. We are going to use a wide variety of equipment in today's lab. Not in any particular order, we will be using the following: balance, spatulas, beakers, 10 ml graduated cylinders, separatory funnel with stopper, Pasteur pipettes and bulbs, ice and ice bath, hot plate, stir rod, and finally the vacuum setup. The vacuum setup includes a ring stand and clamps, hose, filter flask, and neoprene adapter. When we use the vacuum setup for filtration, we will use the Hirsch funnel with filter. When we perform the sublimation, we will be instead using a cold finger. For melting point analysis, we will be using the melt-temp instrument and capillary tubes. The chemicals we will be handling over the course of the experiment are salicylic acid, naphthalene, diethyl ether, sodium bicarbonate solution, concentrated hydrochloric acid, sodium sulfate, and deionized water. Some of the chemicals we will be handling have associated hazards. Salicylic acid is an irritant and is corrosive. Naphthalene is explosive, flammable, and an irritant. Diethyl ether is a general health hazard, flammable, and an irritant. Concentrated hydrochloric acid is highly corrosive and a strong irritant. It will cause chemical burns if spilled on unprotected skin. Due to all of these hazards, we will be working in the fume hood, and we will be wearing proper lab attire, gloves, and goggles. Before we jump into today's lab, let's go over some general lab safety. Here comes a student that is almost ready for lab. She is wearing pants without holes in them and shoes that are closed toe. However, her hair is not tied back and she is wearing a long-sleeved sweatshirt that is not flame retardant or graded for lab chemicals. On her second try, the student is now ready for lab. She ties up her hair with hair ties so that it is out of her face. She puts on her lab safety goggles, and she puts on her lab coat, which is fire retardant and is graded for lab chemicals. The student also double checks her list of chemicals for today's lab and puts on her lab gloves. Let's review some proper lab attire. You must be wearing shoes with closed toe and no height. This means no heels, no platforms, no Crocs, no peep toes, and no sandals. You must be wearing pants or floor-length skirts that do not have any holes. Short sleeves are preferred. If you have long hair, it must be tied back. If you have a long beard, it must be tied up. In every lab, you are required to use the proper PPE, or personal protective equipment, gloves, and goggles. Now let's go over the lab safety stations. The emergency eye wash and safety showers can be found in one of the front corners of your lab. If you get a chemical in your eye, go immediately to the eye wash station, pull down the eye wash station door. The water will start running immediately. Keep your eyes in the stream of the water for 15 minutes. If chemicals are spilled on your body or your clothing, immediately go to the safety shower, remove all of your clothes, pull down the safety shower handle, and throw the curtain around you. In the other front corner of the lab is where you can find the fire extinguisher. The fire extinguisher should only be used if you are confident in its use, the fire is small, or you are using it to escape the fire. Here is where you can also find the glass waste and spill kit. In the event of a spilled chemical or broken glassware, please inform your TA. Your TA will be responsible for cleaning up the mess. The separation of a mixture experiment will be performed over 2 lab sessions. On day 1, we will perform the separation to isolate crude salicylic acid and crude naphthalene. First, we will dissolve the mixture in an organic solvent. Next, we need to make one of the products soluble in water. We will add bicarb solution, which is basic, to deprotonate the salicylic acid. The negative salicate ion is soluble in water. Now that the salicylate ion will be in the aqueous layer and the naphthalene is still in the organic layer, we can separate the 2 layers. We will add acid to the aqueous layer to reform and precipitate the less water-soluble salicylic acid, filter the precipitate, and leave to dry overnight. We will add a water absorbent to the organic layer to soak up any dissolved water molecules. Remove the organic layer from the absorbent to a new beaker, air dry, and leave to dry completely overnight. To begin the lab, we first need to weigh out about 0.7 grams of the salicylic acid and naphthalene mixture. Before placing anything on the balance, make sure it is clean by giving it a quick brush off. Now you can place your weighbow on the balance and close the balance doors. When you are reading a measurement, make sure the doors of the balance are closed to minimize disruptions of the balance. When the numbers stabilize, press the tare button on the balance so that it reads 0 grams. Open the doors and slowly start dispensing the mixture onto the weighbow. As the measurement nears 0.7 grams, stop adding mixture and recap the mixture container. Again, close the doors of the balance to read the measurement. Once the numbers are stable, record the measurement in your lab notebook. Transfer the mixture to a beaker in preparation for the next step. Bring the beaker to the fume hood. Measure out 10 milliliters of diethyl ether into a graduated cylinder. Always use a pipette to transfer your solvents. Using a pipette helps control the volume that is being dispensed and also helps avoid spillage. When measuring volumes, you always want to read the volume at eye level so you can accurately see the level of the meniscus of the solvent. Once you have 10 milliliters, pour it into the beaker containing the mixture and gently swirl to dissolve. Before starting the separation, we need to prepare the separation setup. You will need to attach the ring to the ring stand by securing it tightly with the screw clamp. The circumference of the separatory funnels are smaller than the rings, so we need to also use a wire holder to keep the separatory funnel in place. Take the stopper off of the separatory funnel. Before pouring the dissolved mixture into the separatory funnel, make sure the stopcock is closed by checking to see that it is perpendicular to the spout. Now we can pour the mixture into the funnel. Because ether evaporates very quickly, we will stopper the funnel while we measure out the 10 milliliters of aqueous bicarb solution. Notice that while we were measuring out the bicarb solution, the remaining ether in the beaker evaporated, leaving a thin film of mixture. In order to maintain a good yield, more ether could have been used to rinse the beaker and then added to the separatory funnel. Now we unstopper the funnel and add the bicarb solution and restopper. Be careful that the stopcock remains closed as you remove the funnel from the ring stand. Notice that there are now two distinct layers in the funnel. Because water is denser than ether, the aqueous layer is on the bottom. Now that we have our two solvents in the funnel, we firmly place our finger over the stopper to keep it closed and shake the funnel to mix the solvents together. We always make sure to shake the funnel away from us behind the sash of the fume hood. After shaking, we place the funnel back in the ring stand for the layers to separate, again making sure that we are careful to keep the stopcock closed. We slowly and carefully remove the stopper so that the gas can vent from the reaction of bicarbonate with salicylic acid. We restopper the flask, remove it from the ring stand, and notice that the layers have separated themselves. We repeat the shaking and venting 2 more times to ensure that the solvents have thoroughly mixed. Now that the layers have separated themselves a third time, we will remove the aqueous layer. Remove the stopper from the funnel, otherwise the funnel will not drain. Place the beaker labeled aqueous layer below the spout. Hold the beaker with one hand. With your other hand, slowly rotate the stopcock so that the aqueous layer starts flowing out. As the aqueous layer drains, it will appear to move faster as the funnel narrows. Make sure to adjust the stopcock so that it moves even slower. Stop the flow by turning the stopcock back to perpendicular when the meniscus of the aqueous layer is just above the stopcock. Move the aqueous beaker out of the way to avoid contamination. Add another 10 ml of bicarb solution to the separation flask and repeat the 3 shaking and venting steps. When the shaking and ventings are complete and the layers have separated themselves, we will add the second aqueous layer in the funnel to the one in the beaker. It is important to stop the draining of the aqueous layer so that the meniscus of the aqueous layer is just above the stopcock. If any of the ethereal layer drains into the aqueous layer, it will be contaminated. However, leaving a tiny portion of the aqueous layer behind in the ethereal layer is okay, as we will be adding 4 ml of DI water to it momentarily. Again, move the aqueous layer beaker out of the way and add 4 ml of DI water to the ethereal layer. This will remove any remaining salicylic acid and bicarb salt from the ethereal layer. We will shake and vent. Drain this aqueous layer to a waste beaker. This time, you want to fully drain the aqueous layer so that the ethereal layer starts to enter the spout. This will ensure that no extra water will remain. Move the waste beaker aside, grab a beaker labeled organic layer, and hold it beneath the spout. Fully drain the ethereal layer into the organic layer beaker. Because this is the only remaining layer, you do not have to worry about how fast the solvent is flowing. Now we have our 2 layers in their own beakers. In order to remove any remaining water molecules in the ethereal layer, we add a few scoops of sodium sulfate into the organic layer beaker. We hold the beaker at eye level and swirl. If there are only clumps, that means there is still water present in the organic layer. We need to add more scoops of sodium sulfate. Even though we can't see any water separation, there are enough water molecules dissolved in the ether layer to cause the sodium sulfate to clump. We swirl again and it is still clumping, so we add more sodium sulfate. We add sodium sulfate until the granules of sodium sulfate flow freely in the solvent. Once the sodium sulfate is flowing freely, we know that all of the water is absorbed. When we are finished with the sodium sulfate, recap the material. Now we need to acidify our aqueous layer. We carefully uncap the concentrated hydrochloric acid. We slowly add the acid drop by drop using the pipette. The cloudiness you see is the immediate precipitation of salicylic acid at the site of the acidification. However, it redissolves just as quickly. We need to keep track of the pH, so we take a Pasteur pipette, dip it in the aqueous layer, and dab it on a piece of pH paper. Comparing the spot on the pH paper to the scale, the aqueous layer is still basic. We add more acid, and this time the precipitate remains. We stir the mixture to get maximal reaction and precipitation. Because we have significant precipitate, we test the pH again. However, the pH is still not acidic, so we add more acid and stir. Now the mixture is much cloudier with precipitate. We test the pH again, and the aqueous layer is finally acidic. Now that we are done with the hydrochloric acid, we tightly recap the bottle. Before we can collect our crude products, we need to pre-weigh their respective pre-labeled containers. Make sure the balance is at 0 grams and place the clean and empty beaker labeled crude salicylic acid on the balance and close the doors. Once the numbers stabilize, record the value in your lab notebook. Repeat the step for the clean and empty beaker labeled crude naphthalene. In order to remove the water from the salicylic acid precipitate, we need to vacuum filter the crude salicylic acid. First, we must set up the vacuum filter. Use a screw clamp to attach the 3-fingered clamp to the ring stand at a low height. Place the filter flask on the ring stand and readjust the height of the clamp so that it is level with the neck of the filter flask. Screw the fingers in so that they are snug on the neck of the filter flask. You may readjust the height if needed so that the flask is firm against the bottom of the ring stand. Attach the vacuum hose to the filter flask and to the vacuum nozzle. In our lab, it is the yellow nozzle labeled vac. Place the neoprene adapter in the neck of the filter flask. Place a new filter into the Hirsch funnel and put the Hirsch funnel in the neoprene adapter. Turn on the vacuum. Slowly pour the aqueous crude mixture into the Hirsch funnel. If you pour too quickly, some of the solvent will be sucked up the vacuum. Scrape as much of the precipitate off the sides of the beaker into the Hirsch funnel as you can. Some will inevitably be left on the sides of the glass. In order to make sure air can be pulled through the filter, scrape up the crude salicylic acid. As the air is pulled through the crude product, you can feel that it is getting lighter and fluffier when you are scraping, meaning it is getting drier. However, it is not fully dry. Scrape the crude salicylic acid into the pre-weighed and labeled beaker. We will leave it to dry in the hood overnight. For the crude naphthalene dissolved in ether, we need to transfer the ethereal layer to its pre-weighed and labeled beaker. We do so by pipetting the layer into the pre-weighed beaker, making sure not to suck up any of the sodium sulfate granules. Next, we will evaporate the ether using a light stream of air. Connect the skinny hose to the air nozzle and turn the stream of air on very slowly. You can test the pressure of the stream of air on your gloved hand. Keep the stream of air about an inch above the surface of the ether and let the ether evaporate. Because naphthalene is a very light and flaky solid, we will lightly cover the beaker with parafilm so that any remaining ether can evaporate overnight, but it will prevent the hood from sucking up the crude naphthalene. To finish the day, we need to take care of our waste. The sodium sulfate needs to be scraped into the solid waste container. For the rest, we will need to open the liquid waste container and place the funnel on top. We can then pour in our filtrate and rinse our glassware, filter, and spatula with acetone into the liquid waste. When you are done, remove the funnel and recap the liquid waste container. Bring the glassware and equipment to the sink and give everything multiple rinses with water. If there is anything remaining after rinsing, you should use the scrubbers and soap to wash thoroughly. Leave the glassware to dry at your lab station. On day 2, we will analyze the weights and melting points of our crude products. We will purify the naphthalene by performing a sublimation deposition using the cold finger vacuum apparatus. We will purify the salicylic acid by recrystallization in boiling water, followed by vacuum filtration. Finally, we will determine the weights and melting points of the pure substances. Here is what our crude products look like the next day. They look the same, but hopefully they are dry. Both seem to look like white powders at the moment. Before we do anything else, we need to take the weights of our crude products. Open the balance and wipe off the balance with the brush. Close the balance and make sure it reads 0 grams. If it does not, press the tare button. When the balance reads 0 grams, place the crude salicylic acid beaker on the balance and close the doors. Once the numbers stabilize, record the weight of the vial and crude salicylic acid. To get the weight of the crude salicylic acid, subtract the weight of the beaker which was recorded previously. Make sure the balance is back at 0 and repeat the process for the crude naphthalene beaker. Now that we have the weights of the crude products, we can take their melting points. Carefully take out a melting point capillary tube. The melting point capillary tubes have one open end and one closed end. Tap the open end onto the crude salicylic acid to get it into the tube. Once you have about 2 to 3 millimeters of product in the top of the tube, we need to get the product to the bottom of the tube. We can do this using gravity. We drop the capillary tube down the middle of a glass tube until all of the product falls to the bottom. When the capillary tube is ready, we put the capillary tube in one of the slots in the melt-temp machine and turn it on. In order to increase the temperature, we hit the run button. Because the literature melting point of salicylic acid is 158.6 degrees Celsius, we can start ramping up the temperature on the fastest setting. What is not shown in this video is that when I initially turned on the melt temp, the screen on the machine said it was not calibrated. This will be important when we think about the error in the experimental melting points. When we are about 20 to 15 degrees from the literature melting point, we want to slow down the temperature ramping. We will run the melt temp at the lowest setting, 3 degrees Celsius per minute, until we reach the melting point. As we get closer to the melting point, you can see the morphology of the product start to change. However, melting does not start until you see liquid forming. By rotating the tube, we can check to see what the product is looking like on all sides of the tube. That is helpful for monitoring the progress of the phase change. At about 159 degrees Celsius, we can see that the product is starting to melt. Melting is finished when there are no more solid crystals left. It finishes melting at 162.3 degrees Celsius. We press the run button again to stop the temperature ramping. The capillary tube containing our melted crude salicylic acid can be thrown away in the satellite capillary tube waste on the bench or the glass waste. The crude naphthalene product is stuck to the beaker, so we scrape the product off the glass. We carefully obtain a new capillary tube and tap the crude naphthalene product with the open end until we have about 2 to 3 millimeters of product. Again, using gravity, we want to drop the capillary tube through the glass tube. However, the naphthalene is staticky, so it will not work. Instead, I firmly but carefully tap the capillary tube against the bench until it falls to the bottom of the capillary tube and is reasonably packed. Make sure that the temperature of the machine is below the literature melting point of naphthalene. Place the capillary tube into the melt temp. The melt temp is still warm from the previous run, and naphthalene's literature melting point is 80.3 degrees Celsius, so we ramp the temperature a bit slower. As we approach the melting point, again we can see the morphology start to change. We know that naphthalene sublimes, so we maintain the temperature ramping at 6 degrees Celsius in the hopes that we get melting instead of sublimation. When we are 5 degrees Celsius away, we slow to 3 degrees Celsius per minute because we do not see evidence of sublimation yet. At 80.9 degrees Celsius, we start to see liquid form. At 83.9 degrees Celsius, the crude naphthalene is completely melted. We turn off the machine and dispose the capillary tube into the satellite capillary waste on the bench. To purify the crude naphthalene, we are going to perform a sublimation deposition. The hot plate was placed on the base of the ring stand, and a 3-fingered clamp has been clamped to the ring stand. Scrape as much of the crude naphthalene crystals as you can into the 25 milliliter Erlenmeyer filter flask. Unfortunately, you will not be able to get all of the crystals from the beaker into the filter flask. Using the 3-fingered clamp, secure the filter flask with the crude naphthalene crystals to the hot plate. We will not be attaching anything to the filter flask nozzle. Obtain a cold finger with a neoprene adapter and fill the cold finger with ice. Wrap a Chem wipe around the neoprene adapter on the cold finger to help avoid condensation dripping into the flask. Place the cold finger wrapped in Chem wipe into the filter flask. Turn on the hot plate and set the temperature to about 60 degrees Celsius. As the naphthalene crystals are heated, they will sublime and then deposit on the cold finger. The crystals on the cold finger will be pure naphthalene. It will take a while for the sublimation to start, so we can move on to the recrystallization of salicylic acid while we wait. First, we prepare the filtration setup so that it is ready when we are done with the recrystallization. As before, clamp the filter flask to the ring stand. Attach the hose to the flask and the vacuum nozzle. Place the neoprene adapter in the neck of the flask. Place the filter in the Hirsch funnel and place the funnel in the neoprene adapter. We have deionized water cooling in the ice bath, which will be used for washing our pure crystals during the filtration step. We obtain room temperature deionized water from the deionized water tap and heat it to boiling on the hot plate. As soon as the water starts boiling, we can add it to the crude salicylic acid using a Pasteur pipette. With water in the crude product beaker, place that beaker on the hot plate. Keep adding boiling water to the crude product until all of the crude product is just dissolved. The manual says that it will take 0.5 mils of boiling water. This is most definitely not the case since salicylic acid has a low solubility in water. The idea with recrystallization is that the impurities will be more soluble in the water than the product, which is why we need to heat in order to dissolve the salicylic acid. Since we do not know how much water it will take, it is important to add the boiling water very slowly once the salicylic acid starts to dissolve. In order to get a good amount of crystals during recrystallization, we need the dissolved salicylic acid to be saturated. Once the salicylic acid is finally all dissolved, we turn the temperature of the heat down to 0, remove the beaker and place it on the bench, and turn off the hot plate. We will leave the beaker to cool to room temperature. As the beaker cools, precipitate starts to form. This time, the precipitate should only contain salicylic acid, as the impurities should still be soluble in water as the water cools. Once at room temperature, we place the beaker in the ice bath to further crystallize the salicylic acid. We also use a glass stir rod to scratch the glass. The disturbance causes more product crystallization. When we no longer notice more crystallization, it is time to filter the pure salicylic acid. Turn on the vacuum and slowly pour the water with the pure product through the Hirsch funnel. Scrape as much of the crystals as you can into the Hirsch funnel. Because there are still crystals in the beaker, we will rinse it with ice-cold water and pour it into the funnel. We use ice-cold water to avoid dissolving any product while rinsing out any impurities from the product in the funnel. Now we want to scrape the product to make sure that air is being pulled through the crystals and to test the dryness of our crystals. We allow the vacuum to pull air through the crystals for a few minutes to dry the crystals further. As we wait for both sets of pure crystals, we need to weigh the clean, pre-labeled beakers that we are going to transfer them into. We make sure the balance is at 0 grams, place the empty pure naphthalene beaker on the balance, close the doors, wait for the numbers to stabilize, and record its weight. Then we repeat the process for the empty pure salicylic acid beaker. While we were performing the recrystallization of salicylic acid, crystals have begun forming on the cold finger. In order to get more sublimation and deposition, we need to scrape off these crystals. Remove the cold finger from the flask very slowly to avoid crystals falling off. Scrape the crystals into the pre-weighed and pre-labeled pure naphthalene beaker. Replace the cold finger in the filter flask. Because the hot plate is heating the crystals, the ice in the cold finger will also melt. Use a pipette to remove the water from the cold finger and dispense it into a waste beaker. Once all of the water is removed, refill the cold finger with ice. We will repeat the crystal scraping and cold finger refilling multiple times until all of the crystals have sublimed and only impurities are left. With the pre-weighed and pre-labeled product beaker in hand, we check to see if the pure salicylic acid crystals are dry. They seem dry, so we turn off the vacuum, remove the funnel from the flask, and scrape the pure salicylic acid into the beaker. The cold finger is once again covered with pure naphthalene crystals. We will scrape them off for the final time. In a moment, we will see that there are no more naphthalene crystals on the bottom of the flask, but the sides are covered with possible impurities or deposited naphthalene. Now we can turn the temperature of the hot plate down, turn off the heat, and turn off the hot plate. Look at those beautiful naphthalene crystals. Before we do any further analysis on our pure products, we must take their final weights. Make sure the balance is set at 0 grams. Open the balance door, place the beaker with the salicylic acid on the balance, close the door, and wait for the balance to stabilize. Record the weight in your lab notebook. Repeat this process with the pure naphthalene beaker. Subtract the weight of the empty beakers that we obtained previously from these weights to get the weights of just the pure crystals. Now that we have the final weights, we can take the melting points of our pure products, turn on the melt temp. We will start with the naphthalene because it has a lower melting point. That way, we won't have to wait for the machine to cool in between products. Obtain a new capillary tube and carefully tap the open end onto the product until you get 2 to 3 millimeters of product in the tube. It takes longer to get enough pure naphthalene in the capillary because pure naphthalene is in flaky sheets rather than a powder. Thinking that the glass tube is still staticky, we tap the tube carefully and firmly on the bench to get the naphthalene to fall to the bottom of the tube. As we tap the tube, we start the temperature ramping of the melt temp. Tapping is taking too long, so we try the glass tube, which is no longer staticky and allows the capillary to drop. We do this a few times until the naphthalene is at the bottom of the capillary. We place the capillary in one of the slots of the melt temp and ramp the temperature fast until we get about 10 degrees below our literature melting point, and we slow to 3 degrees Celsius per minute. Again, as we approach the melting point, the morphology of the crystals start to change. At about 81.1 degrees Celsius, the crystals are definitively melting. The pure naphthalene finishes melting at 84 degrees Celsius. We dispose of the capillary tube and the capillary tube satellite waste. We can let the melt temp continue to slowly ramp while we prepare the salicylic acid capillary tube because the melting point of salicylic acid is about 80 degrees higher at 158.6 degrees Celsius. Obtain a new capillary tube and tap the open end on the pure salicylic acid until you have 2 to 3 millimeters of product in the capillary. We tap the salicylic acid capillary tube on the bench and the product starts to fall. We try the glass tube, but it is now too staticky. We keep tapping until the product is at the bottom of the capillary, put it in the slot of the melt temp, and ramp up the temperature faster. When we are 10 degrees from the melting point, we put the ramping on the slowest setting. Again, the morphology starts to change as we approach the melting point. The pure salicylic acid starts melting at 161.1 degrees Celsius and finishes at 164.6 degrees Celsius. Both crude melting points were within 1 degree of their literature values with a range of about 2 to 3 degrees each. The pure melting points were about 1 degree higher with the same range. This consistency in the difference between the crude and pure melting points of two very different compounds leads me to believe that the discrepancy could be due to the melt temp not being calibrated rather than impurities, especially due to the perfection of the naphthalene crystal morphology. This would mean that the error in the melting points is probably a systematic error rather than a random error. However, that might not be the case in the melting point data given to you in the datasheet on Blackboard, so please look carefully at those melting points and those melting ranges. The last thing to do before we leave is clean up our workspace. Dump the ice bath into the sink and hang the bucket to dry. Bring the equipment to the waste hood. Dispose of the solid waste in the solid waste container. In a normal semester, you would save your product for your TA to grade rather than disposing it in the solid waste. Open the liquid waste and place the funnel on top. Rinse all of the equipment with acetone into the liquid waste. Dispose of any other liquid waste into the liquid waste container. When you are done, remove the funnel and close the liquid waste container. Close the hood and then rinse or wash all of the equipment in the sink. Then leave it to dry at your bench. Thank you for watching today's virtual lab. Remember to use the data sheet provided to you on Blackboard for your lab report. Please contact your TA with any further questions.